My goal in this tutorial is to give you a broad understanding of how rectifiers work. Also, I won't go into the deep details of semiconductor physics or equivalent models. But we will look enough at the operation of rectifiers to understand how rectifiers can be used. Rectification is the process of converting an alternating voltage source to a DC voltage source or direct current using diodes, thyristors, transistors, or converters. This rectification process can be performed with various half-wave, full-wave, controlled and fully controlled rectifiers to convert single-phase and three-phase sources to a constant DC level. In this tutorial, we will introduce half-wave rectifier. Half-wave rectifier. Rectifiers are one of the main blocks of AC power conversion with half-wave or full-wave rectification and generally use diodes for rectification. Diodes pass alternating current in the forward direction and block it in the reverse direction. As a result, they can produce DC voltage. Of course, the current rectified by diodes, like batteries, is not pure and has wave-like variations in the output caused by the AC source. It should be noted that the signal we want to correct is an AC waveform with a fixed maximum amplitude and frequency. A sine wave shape is generally defined by two numbers or parameters. The first number is the degree of rotation of the waveform along the x-axis, which ranges from 0 to 360 degrees. This value is called the period, t, and specifies the interval that the waveform oscillates in one complete cycle. Periodicity is measured in terms of degree and time. The relationship between period and frequency of a sinusoidal waveform is t equals 1 over f. The second number specifies the current value or the voltage range on the y-axis. This number is the instantaneous value from 0 to peak or maximum. V max, A max, I max. The waveform shows the largest amplitude before reaching 0 again. For a sinusoidal waveform, there are two peak or maximum values. One for positive half cycle and one for negative half cycle. Similar to these two parameters, there are two values related to rectification. One of these values is the average value and the other is the RMS value. The average value of a waveform is obtained by summing the instantaneous values of voltage or current in a half cycle and is equal to 0.6365 Vp. Since the sine waveform is symmetrical, its average value over a complete period is 0. The RMS, root mean square, or RMS value of a sine waveform transfers the same amount of energy to a resistor as a DC source of the same amount does. The effective value of a sinusoidal voltage, or current, is equal to 0.7071 Vp. Half-wave rectifier circuit. All single-phase rectifiers use semiconductor components. Single-phase uncontrolled half-wave rectifiers are the simplest and perhaps the most widely used rectifier circuits for low power levels because they are affected by the connected load impedance. In uncontrolled rectifier circuits, semiconductor diodes are the main components and are arranged to form a half-wave or full-wave circuit. The advantage of using diodes as a rectifier component is that, depending on the design, they are unidirectional components and have a unidirectional PN junction. This PN junction converts half the waveform of a bidirectional AC source into a unidirectional waveform. For example, when the diode is forward biased, it can go through a positive half cycle. While when the bias is reversed, it removes the negative half cycle. A single-phase half-wave rectifier configuration passes the positive half cycle of the AC source waveform and removes the negative half cycle. A pulsed DC output means that the equivalent DC value across the RL load is the average value of only one half sine wave. Since the maximum value of a sine waveform is 1, the average DC value of the waveform is 0.637x the maximum amplitude value. Therefore, for a half-wave rectifier, 50% of the time of a period, the average value is 0.637 times a max. And for the other half-wave, the average is 0. If the maximum amplitude is equal to 1, the DC value or equivalent average load RL will be. Therefore, the expression for the average value of voltage or current for a half-wave rectifier is. Note that in addition to the maximum or max value of the input waveform, we can also use its RMS value to find the equivalent DC output value of the single-phase half-wave rectifier. To determine the average half-wave rectifier voltage, we multiply the RMS value by 0.9 form factor and divide by 2. As a result, we have the half-wave rectifier circuit converts the positive or negative half-waves of the AC waveform into a pulsed output with a value of 0.318 times a max or 0.45 times arms.
Disadvantages.
One of the main disadvantages of a single-phase half-wave rectifier is that half of the input waveform is missing from the output, resulting in a low average value. The only way to overcome this problem is to use more diodes to form a full-wave rectifier. In the following tutorials, we will introduce this rectifier.
Sample question. A single-phase half-wave rectifier is connected to an alternating source with an effective voltage of 50 V and a frequency of 50 Hz. If we use a rectifier to supply a resistive load of 150 ohms, find the DC voltage and current of the equivalent load and its dissipated power. Assume that the characteristic of the diode is ideal. Write your sample answer in the comments so I can pin the correct and complete answer. Thank you.